Hello everyone. In this video, we are going to study about separate chaining, which is a collation resolving technique in hashing. First, we will see introduction about hashing and its related concepts. Then we will see what collation is, and at last we will cover separate chaining. Hashing in data structure is basically a technique of mapping a large amount of data into a small table using a hash function. The values are then stored in a data structure called hash table. Hash function maps a bigger string or number into a smaller one, which is then used as index in our hash table. Hash tables use a technique to generate these unique index numbers for each value is stored in an array format. Now, what is the need for hashing? It is done for faster access to elements. Efficiency of mapping depends on the efficiency of the hash function used. Now, let us look into an example to understand hashing. We have a list of values and a hash function which is x mod 10, where x is the value. We will start with the first value. 10 mod 10 is 0. So at index 0 in hash table, we will put value 10. Next, 12 mod 10 is 2. So at index 2, we will put value 12. Next we have 15 mod 10 is 5. So at index 5, put value 15. Similarly, 16 mod 10 is 6. So at index 6, put value 16. At the end, we have 17 mod 10, that is 7. So at index 7, put value 17. What is collation? Since a hash function gives us a smaller number or string, there is a possibility that two keys result in same value. For example, two people can have their birthday on the same day. The situation where a new key maps to an already occupied space in hash table is called collation. To avoid collation, we have two collation handling techniques: separate chaining and open addressing. The basic idea of separate chaining is to make each cell of the hash table to point a linked list of records that have the same hash function value. Let us consider an example. We have a hash function which is x mod 10. Here, x is the key which we want to map to. The range of this function will be 0 to 9. So we will have a hash table as shown. The keys we have are 0, 1, 4, 9, 16, 25, 36, 49, 64, and 86. We start with the first key. 0 mod 10 is 0. We put 0 at index 0. Next, 1 mod 10 is 1. So put 1 at index 1. Similarly, we will get index values for 4. 4 mod 10 is 4. So at index 4, put value 4. 9 mod 10 is 9. So at index 9, put value 9. 16 mod 10 is 6. So at index 6, put value 16. 25 mod 10 is 5. So at index 5, put value 25. Now, 36 mod 10 is 6, which is a case of collation since we have already put 16 at index 6. So, we create a slot and link it to the slot with the same hash value. Hence, link slot with key 16 to a slot with key 36. Next, 49 mod 10 is 9, another case of collation. We create a linked list of hash value 9 and add a node to it with key as 49. Then 64 mod 10 is 4, another case of collation. We create a linked list of hash value 4 and add a node to it with key as 64. At last we have 86 mod 10 that is 6. Again, a case of collision. We add one more node to our linked list with hash value 6. So, this is how our hash table will finally look like. Now, let's have a look at some of the advantages of separate chaining. It is a very simple method to avoid collision and hence can be implemented easily. Hash table can grow and we can add new elements to it. It is less sensitive to the hash function used. This method can be used easily when we are unaware about the number of operations like insertion and deletion to be performed with the keys. Now let's talk about few disadvantages of separate chaining. Wastage of space, as some slots of hash table are never used, as we have seen in a previous example. If a majority of keys hash to the same value, then linked list grows and search time becomes big O of n in the worst case. Last disadvantage is we waste extra memory to save link address. With this, we come to an end of this video. Thank you for watching.